Hello students, we're starting a new unit today, unit 4B.1, and today we are going to talk about simplifying, multiplying, and dividing rational expressions. Well, let's go kind of down memory lane just for a moment and remember a few things that you should know at this point in high school. First off, if we want to simplify these expressions and assume that all variables are not zero, and we're assuming that they're not zero because if we had a zero in the denominator, like 0 squared is 0, we'd have an undefined expression, something that would cause a problem. So we're kind of just saying that they don't exist in these examples. So if I'm going to multiply x to the fifth times x squared, you should remember that when you're multiplying like bases, you add the exponents. So we get x to the seventh because 5 plus 2 is 7. Y to the third times y to the third. Again, you add the exponents to get y to the sixth power. 3 plus 3 is 6. If we are dividing, instead of adding the exponents, we subtract them. And you can, if you just have x's and y's, you can just subtract towards the bigger number, and that's where it'll end up. 6 minus 2 is going to be 4, so x to the fourth. But the bigger number is in the denominator in example 4, so we'd subtract down and say 5 minus 2 is 3, but the y to the third power would be in the denominator. We'd leave a 1 on the top, so 1 over y to the third. So that's a little bit of review. Also, let's review factoring really quickly. Something that I told you at the beginning of the year that you would see over and over and over again, and that has been the case, hasn't it? So if we're going to factor x squared minus 2x minus 8, in the simple one, we want to ask ourselves, what multiplies to give us negative 8, but adds to give us negative 2? And we find that it is negative 4 and positive 2. Negative 4 times 2 is negative 8. Negative 4x plus 2x gives us negative 2x. So we have factored this. In number 6, I notice a common factor. They both terms have a factor of x. I'm going to divide the x out of both terms, which will leave me with x minus 5 behind. Both of those divided by x give me x minus 5. I also have a common factor in number 7 of, remember when you have two variables, the common factor is the smaller one. So with x to the fifth minus 9x to the third, we have a common factor of x to the third. So the first thing that we'll do is we'll factor out that common factor of x to the third, which leaves us with x squared at the beginning. X to the fifth divided by x to the third is x squared, and minus 9 on the right. And you should notice that this is the difference of two perfect squares, x squared minus 9. So that itself would factor to give us x plus 3 and x minus 3. So final factored form would be x to the third times x minus 3 times x plus 3. So just a quick review of some things before we get started. We need to know that a rational expression is basically just a fraction with polynomials that include variables in the top and the bottom of the fraction. So they're going to have some special qualifications, some special things for us to think about as we work with these problems. The steps to simplify are fairly simple. We're going to factor the numerator and the denominator, if we can factor. We're going to state any excluded values, and these are things that would cause us to have a denominator equal to 0. So anywhere we have an x in the denominator, we're going to set it equal to 0 and solve. And then finally, we'll simplify by canceling out any like factors on the top and the bottom. So in example 1a here, we're going to simplify and then identify any x values for which the expression is undefined. To simplify here, we have got 10x to the 8th on the top and 6x to the 4th on the bottom. You want to notice that 10 and 6 are both divisible by 2, so we'll divide them both by 2, giving us a 5 here and a 3 here. So that 10 over 6 reduces to 5 over 3. And remember, when you divide with like bases, you can subtract the exponents. So we'll subtract 8 minus 4 to get 4. And we're going to keep that on the top in the numerator since the bigger part is in the top. So it'll be x to the 4th in the top over 3. Now, when you are stating the excluded values, the x values for which the expression is undefined, you're going to start at the very beginning and set that equal to 0 off to the side. So we're going to say if 6x to the 4th were equal to 0, what would plug in for x that would cause me to get a 0 in the denominator. Well, if I divide 0 by 6, I get x to the fourth equals 0. And if I take the fourth root of both sides, I find that x is 0. And this is the excluded value for x. The domain of this expression, or the x values in this expression, cannot include 0. So off to the side behind this, you might put x cannot be 0. And there is no x in our final answer. And I know that that's kind of, you're thinking, well, there's no x here, so why do I have to check the original expression? Well, the original expression was what we started with. And if we start with a divide by 0 error, that divide by 0 error would cause problems throughout the problem if in fact it were there. If I plugged a 0 in at the very beginning for x, I would end up with an undefined expression, something that is a problem. If I plug it in the end, I don't have that same issue, but you have the excluded value could be with your starting expression or your final expression. You've got to check both. Example 1b, this time we have two polynomials, and at this point when you see x squared, your brain should start thinking, oh, I've got some quadratics here. I'm going to have to factor, or I'm going to have to use some kind of method to deal with these. And in fact, I want you to factor these. It's really the best way to do this. So you're going to factor the numerator, x squared plus x minus 2, and say, well, let's see. If I plug in x plus 2 times x minus 1, first times first would give me x squared. Inside and outside, 2x minus 1x would give me 1x. And then 2 times negative 1 gives me 2. So I can kind of FOIL it out in my brain and check my work. And then I want to factor the denominator as well. And I see again I'm going to have x and x to start with. But I'm looking at 3. So what multiplies to give me negative 3 but adds to give me 2? I think that's going to be positive 3 and negative 1, because 3 times negative 1 is negative 3, but 3x minus 1x is positive 2x. At this point, I'm hoping, my hope is, something in the top is going to factor out with something in the bottom. So at this point, I want to divide out those common factors by canceling them out. X minus 1 is on the top and the bottom, so I cancel it out. It is no longer in the problem. It's not there anymore. I want to make a quick note. You cannot factor out pieces of these polynomials. The only way that you can factor out or divide out a polynomial is if you have exactly the same thing in the top and the bottom, in your numerator and your denominator. Since I have x minus 1 up here and down here, I can cancel it out. It's fine. I can't take a piece of one of these and say, oh, well, there's an x in the top and the bottom here. No, this is a binomial. That binomial will only cancel out with another one that is exactly the same. Right, well, our final answer then, if we've done everything correctly, would be x plus 2 over x plus 3. And at this point, the parentheses, you can include them. That's fine. You don't have to, since there's only one binomial in the top and the bottom. Now, we want to identify any x values for which the expression is undefined. So let's kind of give ourselves some space here. And this time, let's just think about what would cause us to divide by 0 error. Well, in our original one, if we set that equal to 0, we would have to factor it to this guy right here. So we essentially have the excluded values being what plus 3 would give us a 0, and what minus 1 would give us a 0. So x cannot be negative 3, because negative 3 times 3 is 0, and 0 times anything is 0, and we've got to divide by 0 error. So can't have negative 3. It also cannot be positive 1, because that would also give us a divide by 0 error at the very beginning. We'll make this a little longer there. All right, let's move on to the next question. Well, we've got some U-triads, and kind of my idea with the U-triads here is that you would pause the video, give these a go, see if you can answer them correctly. When you've attempted it, restart the video after you've paused it, and check and see if you've got it right, and make any corrections in your notes if you made any mistakes. So pause the video, and when you're ready, start it back up, and we'll see if you got it right. All right, so for example 1C, the first you try it here today, I noticed that 16 and 8 are both divisible by 8, so I divided them both by 8 to get 2 over 1. And since 2 over 1 reduces to just 2, I just put 2 in my final answer. With 11 in the top and 2x or x squared in the bottom, since those bases were both x's, I said 11 minus 2 is 9, and it's in the numerator since the 11 is larger. So I get 2x to the ninth. To state the value for x for which the expression is undefined, I would say, well, it can't be 0 because any 8 times 0 squared would be 0, and that would cause a problem. In example 1D, here I've got some larger polynomials. You know, when you have just monomials like 1C, you just really are kind of canceling things out, dealing with the exponents. But once you get a larger polynomial, then you want to factor first. I cannot factor the numerator. It's going to stay 3x plus 4. But I can factor the denominator. It's going to be 3x plus 4 times x minus 1. And after factoring it, I say, oh, 3x plus 4 is the same as 3x plus 4. So I cancel them out. And technically, they are both going to be 1. So when I cancel them out, there's a 1 left up here and a 1 down here. Well, the 1 left in the numerator needs to be a 1. In the denominator, 1 times anything is that thing, so I keep it as x minus 1, and I get my final answer as 1 over x minus 1. To get my two excluded values, when I factored this, I got 3x plus 4 and x minus 1. If I set both of them equal to 0, and it's okay if you come off to the side to do that and say, oh, what would be 3x plus 4 equals 0? What would I do? Well, I would subtract 4, and then I would divide by 3. That's how I got negative 4/3. If I plug negative 4/3 here, or if I plugged it in up at the beginning, I would end up with a divide by 0 error, and that would be bad. And then I could do the same thing for x minus 1, set it equal to 0. I get x equals positive 1. These are my two excluded values. These are the things that x cannot be, because if they were available for x values, it would cause a divide by 0 error. Let's move on to multiplication. For multiplication, what we want to do is, if you have monomials, just go ahead and multiply top times top and bottom times bottom. It is okay to reduce first, but I find with these, usually I just want to multiply first, so I get one expression and then kind of start canceling things out. But it's okay if you want to reduce the left side first, the right side first, and then multiply them together. That's perfectly okay. There's nothing wrong with that. So let's go ahead and do that. 3 times 10 is 30. I'm going to add 5 plus 3 to get x to the 8th. 3 plus 4 to get y to the 7th. I have my new numerator after multiplying. In the denominator, I'm going to multiply 2 times 9 to get 18. When I multiply exponents or variables with exponents, I add them. So 3 plus 2 is 5. And 7 plus 5 is 12. At this point, I've multiplied numerator times numerator, denominator times denominator, and now I'll start simplifying things. I want to know what goes into both 30 and 18. Well, I know that 6 goes into 30 and 18, so let's try that. 6 goes into 30 5 times, and 6 goes into 18 3 times. So we got 5 over 3 reduces, and that's as reduced as that's going to get. With the variables, I'm going to subtract towards the larger number. So 8 minus 5 is 3, and 12 minus 7 is 5, and I'll put it on the side of the fraction bar where the biggest number is. So my final answer is going to be 5 x to the third, because 8 minus 5 is 3, over 3 y to the fifth, because 12 minus 7 is 5. While I'm circling this up, remember, if you do notice a mistake in my video, it happens from time to time as I'm doing this. If you're the first person to let me know, I will give you some extra credit in some way and reward you for finding that mistake, and then I'll try to fix it for the next person that views it. In example 2b, now we have some polynomials larger than monomials, some binomials. So what we want to do is we want to try to factor them. That's the first thing that you want to do when you're multiplying is just factor. So x minus 3 is already as reduced and factored as it's going to be, and x plus 5 is the same. So if I multiply x minus 3 times x plus 5, I can just put those as one thing in parentheses times the other thing in parentheses. So my top it really is already taken care of. On the left side, I don't have an x squared, but I do have a common factor of 4, and you always want to look for those. So I've got 4 parentheses. I'm going to divide 4x by 4 to get x, and 20 divided by 4 to get positive 5. And then I'm going to factor this right side. It's a difference of two squares, x squared minus 9, and that would factor to give me x plus 3 times x minus 3. Now notice that when you multiply numerator times numerator and denominator times denominator, all these binomials that we factored are just going to be multiplied on the top and bottom with each other, but we want to leave them factored. And the reason we want to leave them factored is now we can start saying, well, is there anything that cancels out with x minus 3? And in fact, there is. Is there anything that cancels out with x plus 5? And in fact, there is. So the only thing that is left in the numerator is a 1, because everything is canceled out. And when everything cancels out, there's still a 1 there. And in the denominator, we have 4 times x plus 3. We do not have to multiply the 4 times x plus 3. We can leave it in factored form and go ahead and circle it. And I'll go ahead and say we are assuming that all expressions are defined, which means that in these examples, I'm not asking you to look for excluded values for x or y. I'm not asking you to tell me what they can't be. I'm just asking you to multiply them, and that's all I want you to do. We've got a few more you tried, so pause the video, give it a go, and then restart the video and see if you got it right. Right, in example 2C, you try it, multiplied all these together to get 20x to the 8th, and in the denominator 30x to the 5th. The 20 over 30 reduces to 2/3. 8's bigger than 5, so 8 minus 5 is 3. I got x to the 3rd in the top. Hopefully that's what you got. Get a little bit of factoring in example 2D. After factoring the numerator, common factor here, no factoring here. In the denominator, I have factored this trinomial to be x minus 4 times x minus 2, and I had a common factor on the right here. At this point, this multiplication sign really can go away. I mean, we don't have to erase it, but really we're multiplying all these things together and all these things together. So all we're going to do is start canceling things out. I noticed that x minus 4 goes away. X plus 3 goes away. And since these numbers are not part of a binomial, I can reduce them, right? They're kind of separate. They're factored out. They're factors. So I can reduce the 10 and the 5 to become 2 over 1, which leaves me with just 2 in the top and x minus 2 in the bottom. Hope you were successful with those. Let's move on to the next topic, which is division. Now, remember when you are dividing fractions, you're still multiplying, but it's keep the first one the same. Change the second one. I'm sorry, change the sign to multiplication and then flip the second one. Change, flip. Keep the first one, change the sign to multiplication and flip the second one. We call this multiplying by the reciprocal, right? We don't actually divide fractions, we multiply by the reciprocal. So we have a multiplication problem after that. So when I have this problem here where it says to divide and assume that all expressions are defined, so I don't have to worry about looking for excluded values for x or y, I'm not actually going to divide, am I? Instead, I'm going to keep the 5x to the 4th over 8x squared y squared. I'm going to change the division to multiplication, and then I'm going to flip the other one to its reciprocal, which is 8y to the 5th on top and 15 in the denominator. At this point, I can start multiplying things together. 5 times 8 is 40. X to the 4th and y to the 5th do not have anything to multiply with, so they're going to stay separate. Just write them next to each other. So 8 times 15 is 120. And then again, I don't have anything to combine with, so I've got x squared and y squared. To reduce this, I'll reduce the 40 and 120. Both of those are divisible by 40. 40 goes into itself one time. 40 goes into 120 three times. And as I am dealing with the variables, it's got 1 on the top, 3 on the bottom. 4 is bigger than 2. 4 minus 2 is x squared. 5 is bigger than 2, so 5 minus 2 is y to the third. And since the bigger ones are in the top, both of those stay in the top. And whenever you have a 1 in front of your variable term, you can kind of drop that 1. You don't need it. So x squared y to the third over 3 would be the final answer. All right, 3B. Similar problem, but now we have some bigger polynomials. So the first thing we're going to do is we're going to change that division to multiplication by keep, change, and flip. When I look at these, I'm going to look at each part separately. If you cannot do all this together at one spot, what you want to do is you want to take the x fourth minus 9x squared off to the side somewhere, factor that, bring it back, take this one over to the side, factor it, bring it back. If you can do it in your head like I do, you're going to notice the common factor of x squared here. So you're going to say, well, x squared times, and divide both of those by x squared to give you x squared minus 9. For this one, difference of two squares. Should be getting pretty good at those by now, I hope. I've got a trinomial down here. So I've got x times x to get x squared. And it looks like it's going to be minus 3 and minus 1 to multiply to give me a positive 3, but add to give me a negative 4. Move over to this guy over here. I can factor out an x squared. Now, I have made a mistake when I copied this down, if you'll notice, and fix that mistake with me. That should be a 4 and not a 2. I apologize for that. That should be a 4, not a 2. I apologize for that. So we got x to the fourth plus 2x to the third minus 8x squared. I'm going to factor out an x squared, leaving behind x squared. Let's see, plus 2x minus 8. And I'll notice that I haven't completely factored everything. And rather than rewrite everything, I'm just going to kind of come up top here and put that this is the difference of two squares, giving me x plus 3 and x minus 3. And that this is going to factor to give me, let's see, minus 4, nope, plus 4, minus 2, because 4 times negative 2 is negative 8, and 4x minus 2x is positive 2x. And from here, I'll start looking for like things. I noticed that x squared, that monomial, and x squared here can cancel out, so those both cancel out, they're gone. I've got an x plus 3 up here, but no x plus 3 down here. We've got an x minus 3 here and an x minus 3 in the bottom, in the denominator. X plus 4 is going to cancel out, but x minus 4 is not. All right, so at this point, you have to be careful and make sure that you've accounted for everything. What's left behind in the numerator is x plus 3 and x minus 4. What's left behind in the denominator is x minus 1 and x minus 2. And since we are not worrying about excluded values here, we're assuming that everything is defined. We can circle this, and we got it. So this one was a little bit more messy, wasn't it? And sometimes they are, and sometimes they're not, and you just have to do your best when you get to one that looks a little messy. Use all the rules for factoring that you've learned, and try to get it done. We've got some of you try it, so pause the video, try these out, and then resume the video when you're ready to check your answers. All right, for example 3C, hopefully you keep change flipped, kept change to multiplication, flipped. I then, in this case, went ahead and multiplied my numerator and denominator to get them together, and then reduced, leaving me with 3 on the top, x squared on the bottom, and y on the top. 3D got a little bit more messy because, let's see if I can move this down a little bit. Got a little bit more messy because you had some factoring to do. After you keep, change, flip, and factor, you cancel out everything that you can get rid of, and what's left behind here, there's a little 4 over here that was a common factor that's still here, and an x minus 4 that's still here in the top, and then x plus 3 was the only thing in the bottom, so I was able to simplify it down to 4 parentheses x minus 4 close parentheses over x plus 3. Well, that is it for this topic. You've got a lot of practice to do over the next day or two. Um, Hopefully, you're still strong with your factoring, and you are realizing that that factoring is very useful in Algebra 2. If you're still struggling with the factoring, it's something that we really need to get on lockdown because you're going to see it again and again throughout this year, throughout the second half of the school year. Well, I hope that you are good with this material, that you are successful when you try the practice problems, and I will see you in class.